Good afternoon to all. During the last two classes, we were studying about acids, bases and salts. We get a general idea about what are acids, what are bases and what are salts, how salts are formed. Today, we are going to discuss about indicators. I already said that we studied about acids and bases. Then, now we can study how we can identify an acid or a base. There are some substances by which we can identify a substance whether it is acid or a base. Such substances are called indicators. Therefore, we can define indicator that indicator is a substance by which we can identify a substance whether it is acid or base. The given substance can be identified by using indicators. There are indicators are classified into one, natural indicators. Natural indicators. Natural indicators are those which are natural origin, which we obtained directly from the nature. That are natural indicators. For example, litmus, turmeric, red carbon, etc. They are natural indicators. We obtained directly from the nature. By the change of color, we can identify the substance, the given substance is acid or base. We have already seen that litmus is, in acids, litmus shows red color, in bases, it shows blue color. Then the second type of indicator is synthetic indicators. Synthetic indicators are those which are produced in the laboratory. We are artificially prepared indicators are called synthetic indicators. For example, methyl orange and vinagre. Methyl orange and vinagre. They are synthetic indicators. Then the third type is olfactory indicators. What are olfactory indicators? We can identify a substance whether it is acid or base by its smell or odor. Olfactory indicators changes its smell or odor, O-D-O-U-R. Odor means smell itself. In acid, it will produce one smell, and bases it produce another smell. By changing the smell in acid and bases in different smells, we can identify a substance. Such indicators are called olfactory indicators. For example, onion, clove, and vanilla, etc. Olfactory indicators. And the fourth type is universal indicator. universal indicator. This is the most important type. It is a pH indicator. pH indicator means it is a mixture of solutions of several compounds. It's a mixture of a solution of several compounds by which we can measure the concentration of hydrogen ions in a solution. It is obtained either in the solution form or in the paper strip form, like litmus paper. So, these are the 4 different type of indicators. What are indicators? Indicators are used to identify whether the given substance is an acid or a base. Indicators are substance by which we can identify whether the given substance is an acid or a base. Such a substance are called indicators. We can distinguish an acid and a base by change of its color or smell. In acids, it shows one color, and base shows another color. By change of its color, we can identify the given substance is an acid or a base. That is, there are 2 types. By changing color, there are 2 types. Natural indicators, which are natural in origin. We get directly from the nature. Examples of natural indicators are litmus, turmeric, and red cardus. Then indicators are same. They show different color in acids and bases. They are produced in laboratory, so they are called synthetic indicators. They are artificially prepared in laboratory. They are methyl orange and naphthalene are examples. So, synthetic indicators. Then the third type is olfactory indicators. Olfactory indicators which changes its smell or odor in different substances. That is acids and base. For example, the onion we use in the kitchen, the same onion. Chlorine, we know the smell of chlorine, and there shows different smells, different odors in acids and bases. The other type is universal indicator. Universal indicator is it is a pH indicator. pH indicator. We are going to study what is pH. It is pH indicator. It is a mixture of solution of several compounds. That is called a universal indicator, by which we can measure the concentration of hydrogen ions in a solution. Then we can calculate the strength of hydrogen ion as well as the hydroxide ions. Then these are the different types of indicators. Then there is another thing in your test, that is acids in water. Acids in water. We already studied how to dilute an acids. By diluting acids, we add acid drop by drop to water and stir well. On mixing acids, it produces. On dissolving acid in water, it produces hydrogen ions. HCl, hydrochloric acid, when dissolves in water, it produces hydrogen ions as well as hydroxide ions. This hydrogen ion cannot exist alone. It is unstable. This hydrogen ion immediately combines with the water molecule to form hydronium ion. This hydronium ion is stable. All acids shows common properties due to the presence of these hydronium ion. Why acids show common properties? Acids shows common properties due to the presence of hydrogen ion or hydronium ion. Acids show common. We have already studied the common properties of acids. They are sour in taste, they are corrosive, they react with the metals to produce hydrogen, they react with the carbonate and bicarbonate to produce carbon dioxide. They react with the acids, react with the bases to form salt and water. All acids show these common properties. Why? Acid shows common properties due to the presence of hydrogen ion or hydronium ion. Both are correct. The acids produce hydrogen ion first. At the same time, it combines the water molecules to produce hydronium ion. Acids show acidic property only in presence of water. Aqueous solution of acids produce water solution. Aqueous also acids shows acidic properties. If there is not the absence of water, acids does not dissociate, it does not produce hydrogen ion, so it does not shows any acidic properties. In your textbook there is given an experiment. That is, sodium chloride is taken in a test tube, but you know sodium chloride common salt, stable salt, and sulfuric acid is added to this. H2SO4 is added to this. Sodium chloride reacts with the sulfuric acid to produce HCl. Hydrochloric acid, hydrogen chloride acid is produced. Sodium chloride reacts with sulfuric acid to form sodium sulfate and HCl. We show a litmus paper, a blue litmus paper produced here. It shows no color change. At the same time, if we show a wet litmus paper, this is dry litmus paper. This is wet litmus paper. If this dry is produced, show a dry litmus paper above here, and at the same time a wet litmus paper. This dry litmus paper shows no color change. It is blue, both are blue. At the same time, the wet litmus paper shows changes into this blue color changes into red. What does this activity shows? For every activity, there are some requirements. What are the materials used? Material used are sodium chloride, sulfuric acid, test tube. On heating, it produces. Then the procedure, activity. So, sulfuric acid is added to sodium chloride, HCl gas is produced. Then what we do? Take two litmus papers. What are the two litmus papers? One litmus paper, one dry litmus paper, and the second one is wet litmus paper. One dry litmus paper which is blue in color, and the second one wet litmus paper which is both are blue in color, which is shown in the above the test tube. The HCl gas come into contact with the dry litmus paper and at the same time wet litmus paper. The dry litmus paper we can take no color change. Why? All acids produce hydrogen in presence of moisture or water. Why? Acids undergo dissociation in the presence of aqueous solution or the presence of moisture. In the dry litmus paper, there is no moisture. The acid does not produce no H plus ion. At the same time, the wet litmus paper, there is moisture. When the HCl paper come into contact, HCl gas come into contact with the wet litmus paper, it undergoes dissociation, produces H positive ions and changes its color. What does this activity show? What is our conclusion? Acids show acidic property due to the only in presence of water or moisture or in aqueous solutions only. Acids shows acidic properties only in presence of moisture or water only. By acids produce H plus ions only in presence of moisture or water. If it is dry or the absence of moisture or absence of water, it does not produce H plus ions, so it does not show acidic property, so it does not change the blue color of the litmus. We already studied that acids turn blue litmus paper. The litmus paper is red in color acids at the same time blue in alkalis. Then we have to put the next topic, bases in water. Similarly, like acids, bases also when dissolved in water it produce hydroxide ions. Bases also produce hydroxide. All bases shows common properties. We already studied the common properties of bases. What are they? Bases are bitter in taste, soapy in touch. Then they react with the acids to form salt and water. Certain bases react with the metals to form hydrogen. Not all the bases react with all the metals. Certain metals like zinc or magnesium react with the bases to form sodium cincate and hydrogen. So all bases shows common properties due to the presence of these hydroxide ions. Due to the presence of those hydroxide ions. In your textbook, there is some reference to cations and anions. You have to say what the cations and anions. During the first chapter, during the electrodes of water, we have studied that during the electrodes of water, using graphite electrodes, we get hydrogen at the cathode and oxygen at the anode. Electrodes of water. The electrode connected to the positive terminal of that cell is called anode. This is anode. The electrode connected to the negative terminal of the cell is called cathode. Here we say acidic water. First you have to understand what is anode and cathode. Anode and cathode. Anode is the electrode connected to the positive pole of the cell. Or anode is the positive electrode. Cathode is the electrode connected to the negative pole of the cell. Negative pole of the cell. Do you know the symbol of a cell? The symbol of a cell is like this. This is negative pole, this is positive pole. If two cells are used, this is negative cell and this is positive pole. The electrode connected to the negative pole is called cathode and the electrode connected to a positive pole is called anode. Then we have taken this is acidified water. Acidified water is also contain H positive ions and OH negative ions. Pure water does not conduct electricity. To conduct electricity, we add some acid or salt to it. So we are called acidified water. On passing electricity, where we get hydrogen? We get hydrogen at the cathode, and hydroxide come here at the anode and liberates oxygen. For OH equal to H2O plus O2. We have come to know what about cations and anions. That is our main point. Then hydrogen came to the cathodes and liberates from the hydrogen to the cathode. And at the same time, hydroxide ions reach the anode and liberates oxygen. How liberates oxygen? 4OH negative gives 2H2O plus O2. This oxygen is liberated at the anode. That is not our case. Well, now we are studying cations and anions. Then what are cations? These hydrogen liberated, the hydrogen ions moves towards the cathode are called cations. At the same time, the hydroxide ions move towards the anode are called anions. Now what are cations? The charge of the cathode is negative. The charge of the cathode is negative because it is connected to the negative pole of the cell. Or cathode is negative electrode. Cathode is negative electrode, so it attracts positive ions. We already studied lower classes. Like charges repel, unlike charges attract. Cathode negative charge, hydrogen ion positive. So cathode attracts positively charged hydrogen ions. So these hydrogen ions are called cations. Hydrogen ions are called cations. At the same time, what is the charge of the anode? The charge of the anode is positive. How it can be positive? Because it is connected to the positive pole of the cell or the pole. Anode is the positive electrode. Anode is the positive electrode. It attracts negatively charged ions. What are the negative ions? OH negative ions. So here OH negative ions are called anions. Anions. So then what are cations? Cations, what are cations? The positively charged ions which move towards the cathode are called cations. What are anions? The negatively charged ions which move towards the anode are called anions. Yes, so there is a question about what is the charge of anions? What is the charge of anions? Anode is positive charge and the charge of anion is negative. Anions are negative charge. Similarly, what is the charge of the cations? Cation, on hearing the word cation, we means that on hearing the word cation, we slowly says cation. What is cation? Ions move towards cathode. Ions move towards cathode. Cathode is negative charge. Negative charge cathode, which it attracts which ions? Positive ions. So the cations are positively charged ions which move towards the cathode. Charge of cation is positive. Charge of anion is negative. You understand? Only two things you must remember. What are cathode and anode? Normally we say anode and cathode. A, according to English, alphabet anode. Anode positive. Then comes C cathode negative. Anode positive electrode, cathode negative electrode. During electrolysis, anode positive electrodes. Which ions moves towards the anode? Anode positively charged, it attracts negative ions. So anions are negatively charged. Unlike charges attracts. Anode positive charge, it attracts negative ions. That the charge of, you must remember that anions mean negative. Anode positive electrode, anions negatively charged ions. Similarly, cathode negative electrode, cations positively charged ions. During the electrolysis of water, the same thing happened. So, hydrogen, its positive ion, it moves towards the cathode and liberates as hydrogen. Similarly, hydroxide ions, which move towards the anode and liberates oxygen. Oxygen liberates the anode. How it oxygen liberates? Or OH negative, or hydroxide, there is not an element like hydroxide. So, or OH, or hydroxide ions combines together with two water molecules and an oxygen molecule is liberated from the anode. Four hydroxide molecules combine and liberate one oxygen molecule. Then again this process is continuous. Now we have to study about what are cations and anions. You must have a clear idea what is cations and anions. What are cations and anions? What is cations and anions? The positively charged ions move towards the cathode are called cations. What are anions? During electrolysis, anion means anode. The negatively charged ions which move towards the anode are called anions. Now we get to the pH scale. What is pH scale? The concentration of hydrogen ions in a solutions can be determined by pH scale. The concentration of hydrogen ions can be measured by pH scale. It is a tool. pH scale means it is a tool by which we can measure the concentration of hydrogen ion. If we can measure the concentration of hydrogen ion, we can determine whether the given liquid is or the solution is acid or a base. How? If the concentration of hydrogen ion is greater, it is acid. If the concentration of hydrogen ions decreases, acidity decreases. When the concentration of hydroxide ions exceeds hydrogen ion, it shows the property of bases. Then we can see how we can be measured. Now I already said that the hydrogen ion concentration can be measured by using a universal indicator. What is there are four types of indicators, and last one is universal indicator. How we can measure the use it? A universal indicator is a mixture solution of several compounds. It is obtained in the form of solution, either in form of solution or in the form of paper strips. Are you seeing the paper strips? The first class I show you litmus paper. That is the paper strips. This is the universal indicator is also we can purchase from the lab equipments like this is paper strip form. It is commonly used in school labs. It can be obtained paper strip. It is also universal indicator is also obtained in the form of solution. But in school and laboratory we always use the paper strip form. the paper strip. And while we are purchasing the universal indicate form, we also get a color chart. We also get a color chart. In the color chart, there is reading from, it's the value the reading of the starts from 0 to 14. This is the pH scale. You can hear that there's a variation of color change from 0 to 14. This is the pH scale. By using this pH scale, we can rank the acidity or alkalinity of a solution. Now we can study how we can rank the acidity of an alkaline solution. For example, this is the universal indicator we can purchase from the shop. While purchasing universal indicator, I always say that a color chart is obtained. A color chart is this. This is the color chart. This is the pH scale. We take a paper strip. This is the universal indicator. We take a paper strip, one of the strip from the universal indicator, then dip in the given solution. The paper strip is dipped in the given solution. Its color changes according to the concentration of the hydrogen ion. Then we take the pH scale or color chart. Then we can go to which color it matches. To which color it matches to this. Yeah. So the given we can came to the conclusion that the paper strip matches to this color and its pH value is 13. Its pH value is 13. The pH value ranges from 0 to 14. Because in that, if the pH value is 0, it is strong height 0 to more than 0. It reads from 0. It's 1, 0 or 1, it is strong acid. The acidity decreases and it becomes at 7, it becomes neutral. That's the pH value of pure water. Then we see that. Then again the color changes, then it is the bluish color increases. What does it shows? Acidity decreases and at the same time basicity increases. It reaches up to the point of 14. We can say that 14, it is a strong alkali. It is the strong alkali. We can draw it in the table, the blackboard. This is 0, a full hydrogen ion. These hydrogen ions, this is strong acid, this is neutral, this is strong base. This line shows, the shaded color shows the hydrogen ion concentration. Here it is only hydrogen. It is a strong acid. If we pass to 1, 2, 3, 4, 5, 6. We have seen that the shaded portion is the hydrogen ion concentration. Shaded portion is the hydrogen concentration. In the shaded portion, the hydrogen ion concentration, we have seen that decreases. Here decreases and it becomes 7. The hydrogen concentration becomes half. And this is the hydroxide ion concentration and this is the hydrogen ion concentration. At 7, And the pH scale at 7, the hydrogen concentration and hydroxide ion concentration are equal. pH 7. When the pH is 7, H plus ions equals OH negative ions. Then the solution is neutral. Then we can get the conclusion. If then what happens? Then it becomes 8, 9, 10, 11, 12, 13, 14. What happens at 14? At 14, there is no hydrogen ion. This is hydroxide ion. At 14, when the pH value becomes 14, only hydroxide ions. That is, it is our strongest alkali. Strongest why? There is only hydroxide. The concentration, the strength of an acid depends upon the number of hydrogen ions. Similarly, the strength of a base depends upon the number of hydroxide ions. The strength of an acid depends upon the number of hydrogen ions. The strength of an alkali depends upon, or the base depends upon hydroxide ions. This is acid. This is base. When it becomes equal, there is neutral. That is water. It is neither acidic nor basic. When the pH is less than 7, when the pH is less than 7, that means hydrogen ions, pH is less than 7, that means hydrogen ions number greater, hydrogens, that is acidic. Then the pH is greater than 7. What happens? Hydrogen ions less, hydroxide ions more, then it is basic. We understand? There are two things here. What are two things? One, how we can calculate or find quantitatively whether in the given quantitatively the concentration of hydrogen ions or hydroxides. What we are going to do is find quantitatively. Quantitatively means the amount of hydrogen ions. Quantity, the amount of hydrogen ions or hydroxide ions. In the first, by using ordinary indicators, what we do, we only distinguish, we only identify whether the given substance is acid or a base. By using litmus paper or methyl orange, we only identify whether the given solution is or the given substance is either it is acidic or basic. Now, using pH scale, what we are going to do? How strong the acid is, or how strong the base is, or how weak the acid is, or how weak the base is. The strongest acid, we are giving the strongest acid is not 0, not below 0 is possible, below 1 is possible, negative is possible. And above 14 are also possible. That is not in practical cases, that is not possible. If the pH of a solution is 1 or the 0.5, if the pH of a solution is 0.5, it is what is it? It is a strong acid. It is a strong acid. If the pH of a solution is 3, it is a medium. If the pH of a solution is 6, it is a weak acid. The pH of a solution is a 6. What is our conclusion? It is a weak acid. Why? If the pH of a solution is 6, what happens? Hydrogen concentration and there is not much H plus ion shows acidic property. H plus ion shows acidic property. OH negative ion shows basic property. At the pH 7 they are equal. So it neither shows acidic property or basic property. It is neutral. What is neutral? Blood. Our blood is, the pH of our blood is 7.1. Slightly basic. Our pH of blood is 7.4. Similarly, the pH of our saliva in our mouth, it is 6.6. It is slightly acidic. It helps digestion. So, the pH of a solution is 12. It is, we have no doubt, we can clearly say that it is 12. So, pH scale is used. What is use of it? To find quantitatively how strong or how weak the given acid is. Similarly, how strong or how weak the given base is. If the pH of a solution is 7.5, it is we can see that it is a weak base. That means 7. If the decrease from 7, acidity increases. pH 1, strong acid. 2, slight decrease. 3, again decrease. 4 decrease. Then what happens to increase? If the pH increases from 7 to 8, the basicity also increases. Basicity also increases. We can any doubt arise, you do a picture like this, then we can calculate this. Acid shows acid shows acidity when the hydrogen increases. From 0 to 40, hydrogen ion decreases. So acidity also decreases. From 0 to 40, we can see the unshaped part. From 0 to 40, what will happen? Hydroxide ion increases, then basicity increases. Basicity increases. Then we can say, I already know that how we can determine quantitatively by using the universal paper strip. The universal paper strip. How the paper strip is given in the solution, dipped in the given solution. This universal paper strip. It is made use of. It is a solution. It's a mixture of solution of several compounds. It is either we can get it in the solution form. It's convenient. We also get strip. The paper strip form. Then the paper strip is given in dipped in the given liquid. Then what we do? It is going to match with which color it match more. Which color it match more. Then that color, the change in color of the paper strip is going to match with the color chart. Which chart it would match more? That is the pH of the solution. Understand? The change in pH color after dipping the paper strip in the given solution, we take it out and match it with the given 14 colors. To which color it matches most, we stop there. Then that is the pH of the solution. Then when we know the pH of the solution, we can reach unanimously. It is here the pH of the given solution is 13. So we can conclude that it is a base. It is a strong base. 13 means almost strong base. Then there is a question arises. What is the relation between increase in pH and the acidity? Do you understand? What is the relation between increase in pH increase in pH and acidity. Can you say? Increase in pH. pH increases from 1 to 3. Increase in pH and acidity. What is the answer? When the pH increases, acidity decreases. When the pH increases 1, 2, 3, 4, pH increases 1, 2, 3, 4, acidity decreases. There is also discuss again. What is the increase in concentration, increase in pH and the hydrogen ion concentration? Same question. Increase in pH and hydrogen ion concentration. Increase in pH and when increase in pH increases, what is the hydrogen ion concentration? Hydrogen ion concentration decreases. When it is below 1, at 1 hydrogen concentration is highest. When pH increases, hydrogen ion concentration increases. But in the case of base, it is on the reverse order. What is the increase in pH and basicity? What is the increase in pH? pH increases from 7, 8, 9, 12, 13 to 14. pH increases from 7 to 14. What is the basicity? How is basicity? Basicity also increases. Basicity also increases. Then you never bother about much more thing. You have to really want hearing the pH of a solution or a substance or a given substance. You have to identify. You are given 4 solutions A, B, C, and D. A pH 9, B pH 4.5, C pH 7.2, D pH 14. Also, which is the strongest base here? Which is the strongest base? We have no doubt. Which is the strongest base? D. Below 7 there are acids. Above 7 there are bases. 7 neutral. 7 neutral. Above 7 bases. Above 7 basicity increases. Here 14 is the strongest base. What is the weakest base here? We already gave that. Any doubt? You have gained it. What is the weakest base? 7. Any doubt? You throw a pH scale and mark it. 7. 7 is always, when you are trying, 7 is more must in the pH scale. 7. Then what are the given solutions? Here 7.2. Here 9, here 14, the other solution is 4.5. 4.5. Then you write the A. This is A. This is B. This is C. And this is D. Then you can easily find out which is the old muscle. Which is the acid here? B. The resource below 7, there is only this answer here B. Which is the strongest base here? D. Which is the weakest base here? C. Arrange the following. When the again ask one more question. Arrange the following in the increasing basicity of the arrange the following also the increasing basicity. We can increasing basicity means B, least base, C, A, D. The increasing basicity. B is the least base. B is acid means it also contains some hydroxide ions, but concentration of hydrogen ion is greater. Concentration of hydrogen ion is greater. Hydroxide ion is less. So we can came to a conclusion whether the given substance is acid or a base. Are you understand? You must today itself read the passage, then nothing in it, draw a page scale, paging like this, draw this, then mark the following. Then a number of questions are given. There is nothing to know that. You must draw a scale like this. And this mark on the center, you mark this is 7. One side is shade. What is this? This is acid or H plus ion. The unshaded part is called base or OH negative ion. Then we can note out this is class 0 also included or 1 to 14. There is no mistake. Then we can conclude the pH, how the pH varies and the relation between pH scale and hydrogen concentration. At the same time, the relation between pH scale and hydroxide ion concentration. pH scale and hydrogen concentration. At 7 is the medium point, the middle point. Whose pH value is 7? Water, pure water. Okay, we can, you read this passage, we can see the uses of pH scale and daily life, the next class. Thank you all.